Okay, so now we're going to move on to kinematics in 2D. So let's turn to slide 7. So we've been looking at just 1D, so a car driving is only in the X direction, or just vertically, where we're throwing it up and then it drops right down. So it's only vertically, Y direction. But how about for parabolic motion? This parabolic motion will have both X and Y components. So a projectile is an object moving in 2 dimensions under the influence of Earth's gravity. Its path is a parabola. Okay, so again, this has both X and Y directions. It's moving horizontally and vertically. Now let's turn to slide 8. Projectile motion can be understood by analyzing the horizontal and vertical motion separately. So this object is moving and it has a velocity. The velocity vector is moving along the direction of the motion. So it's up and then down. And the velocity vector has both X and Y components. So we're going to look at both the X and Y components for objects in parabolic motion. Notice that the X component adding the Y component will give you that V vector. Okay, so we are going to look at both the X and Y components to help us solve these kinematic problems. So let's turn to slide 9. Let's look at this object in a parabolic or projectile motion. This is the ball at different times. So at the same time intervals, it's going to move at a constant velocity in the X direction. So you see, velocity is distance over time, so it's going to move the same constant horizontal distance per time. So you see that it's the same horizontal distance per time. So write that down in your notes. For the X direction, you have constant velocity. It's the same horizontal distance per time. Okay, so write that down in your notes. Horizontal, for the X components, it's constant velocity. That means that acceleration in the X direction is 0. There's no acceleration because it's constant velocity. So always acceleration in the X direction is 0, always, for projectile motion. Now let's look at the Y component. Y component has constant acceleration because vertically you always have acceleration of gravity, which is downwards of negative 9.8 meters per second squared. So these are 2 balls. One is just vertically dropped, the other one is in projectile motion. And at the time interval, it's moving at the same speed. So at the same time interval, it's moving vertically down. And the balls are at the same vertical position. Okay? Because these balls are moving at the same speed per time. So both of these balls are affected by gravity the same with the same acceleration. Okay. Okay, let's turn to slide 10. So notice here that velocity goes from positive, and here on the top there's only a Vx, there's no Vy. Okay, the tangent of this at the top is this horizontal vector, and that's Vx. So at this high point, Vy equals 0 at this high point. Okay, and then so it goes from positive, the V vector goes from positive down to negative. And we said that horizontally it's constant velocity. So horizontal Vx is the same the whole path. So if you know V naught x, then you know Vx for the whole path. It's going to be the same. It's going to be V naught x the whole path, because in the x direction it's constant velocity. Okay. Let's turn to slide 11. So you remember we have those same 5 equations, or you remember these equations here. So you're going to use the same equations, but there's just going to be one for the x components and the y components, but they're the same equation. So here it's velocity in the x direction, final velocity in the x direction equals initial velocity in the x direction plus acceleration in the x direction times t. So this is all x in the x direction. X equals x naught plus initial velocity in the x direction times t plus 1/2 acceleration in the x direction times t squared. Final velocity in the x direction squared equals initial velocity in the x direction squared plus 2 times acceleration in the x direction times distance in the x direction. And that's for y, everything just in terms of the y direction. Notice that t will be the same in the x and y direction. So at time t, it's gonna get to a horizontal and a vertical point. So at this time, it's the same t to get to a horizontal and vertical point. So we're gonna use t to time to find different values relating to x and y component. Okay, so let's look at slide 12. So we can simplify these equations a lot more. Okay, so for x component, ax is always 0. Okay, so make sure you write that on your notes. So this goes to 0, this goes to 0, this goes to 0. So you're going to simplify the equations in the x direction a lot. Okay, and then for y component, acceleration is always 9.8 meters per second squared downwards. So you always know that a is 9.8 meters per second squared. Okay. So let's do 2 more example problems and then we'll be done. So a movie stunt driver on a motorcycle speeds horizontally off a 50-meter high cliff. How fast must the motorcycle leave the cliff top to land on level ground 90 meters from the base of the cliff where the cameras are? Okay, so again, we're on slide, okay, so turn to slide 13. You have a motorcycle speeds horizontally. What does that mean, right? V naught is a Vx. It's only horizontally, so Vx. We want to look for Vx naught. We know that Vy naught is 0. There's no vertical right there. It's just horizontal speed. Okay. It's a 50-meter high cliff, 90-meter 90 meters from to get to the cameras right here. Okay. So I'm going to choose positive to be the same as the most positive downwards because that's you're going downwards. So I'm choosing it to coincide with the motion. So positive is downwards and right is positive. So I chose the coordinate to be right is positive and down is positive. That's something you choose. So acceleration is always negative. Acceleration of gravity is always negative. Acceleration of gravity is always downwards. So in this case, acceleration is positive 9.8 meters per second squared because we chose downwards to be positive. So acceleration in the y direction is 9.8 meters per second squared. Ax is always 0. I'm choosing that this point where we start is 0. Okay. So when I go down here, I'm going positive y. So it's a positive 50. Because I chose down as positive. So it's positive 50. I'm going down 50, positive, and then right 90, positive, because right is positive. So positive 50 and then positive 90. Okay, so I want to find what V naught is, and yeah, as I said, Vy naught is 0 because it says it's a horizontal speed, initial speed. So I'm looking for Vx naught. Okay, so let's look at the x equations. Or let's look at the slide, back to slide 12. Or slide 11. So this is 0. Okay. So I want to look for Vx naught. So this doesn't tell us anything. We don't have Vx. This doesn't tell us anything because that's also just Vx squared equals Vx naught squared. So that doesn't tell us anything. So this is the only equation we have right here. We have x naught and x. So we need to find t to find Vx naught. How are we going to find t? we're going to look at the y component. Okay, so for a lot of the problems, that's what we're going to do. We're going to find t by looking at the y component and then find something in the x component. Because at the same time, at this time, you're going down 50, right 90. So at this time, it's the same x and y. So, okay. So yeah, at a certain time, it will be down 50 and right 90. So we want to find the time where this motorcycle is going to go down 50 and over 90. So if we find the time that he goes down 50, then we'll know, then we can use that time to find where he went right 90. Okay, so we need to use the y component equations to find time. So we're going to look at these equations right here. Okay, so for this equation, Vy naught is 0, but we don't know what Vy is, so we can't use this to find time. We don't have what we need. For this equation, y naught goes to 0, Vy naught goes to 0. Let's see, do we have all that we need? Yeah. So we have AY, it's 9.8 positive, and we need time, and we have Y. Okay, so let's just plug it in. So Y is the time it goes down 50. So when it goes down 50, what is that time? That's what we want to find out, okay? So 50, and it's positive 50 because we're going downwards. And downwards is positive. Positive 50 equals to 1/2 AY. AY is positive for this scenario. Times 9.8 times t squared, so multiply the 2 over and divide by 9.8. Okay, so t equals square root of 100 divided by 9.8, which equals to 3.19. Okay. So everything's in 3 sig figs, so let's do 3.9. Note that when you're calculating and you use a time, try to just, when you calculate, try to use as many decimal points to just be accurate. But when your final answer, change it to sig figs. So 3.19 seconds. So at 3.19 seconds, it's going to move down to 50. And that's the time that the motorcycle is also going to be moving horizontally 90. So we found the time. Now we're going to use that time to find this x component. Okay. So let's do that. So what do we use here? So we have all that we need now. So x is 90 positive 90 because positive is right. So 90 equals to 0, 0. It was at x equals 0 here. And they're moving to the right. So 0 plus Vx naught. Vx naught is what we're trying to find. Times t. T is what we found. 3.19 seconds. So Vx naught equals, you divide the 3.19 over. .13 meters per second. Or 366, 29.1 meters per second. Okay? Okay, so there, we found the answer. So the motorcycle must have a speed horizontally of 29.13 meters per second for him to reach where the cameras are.